Hi all. So as I have said that in the previous video, that in the next video I'm going to solve a question with the BFS. So this is the question. The question states that we are having a integer x. Okay. So we are given an integer x in the question, and we are given a cyclic graph. What is a cyclic graph? That it does not contains any cycle in it. Okay, so I hope you are aware of a cyclic graph. If not, I'll make you aware of it. With v nodes labeled from 0 to v minus 1, that is obvious, and e edges, return the level of node labeled as x. Okay. And level is the minimum number of edge that you must traverse from 0 to some target. Okay, if it there does not exist a node is that is labeled as x, then return -1. Okay, so let us take the example. So here the integer or the element that is given to us is x equals to 4. Okay, so for 4 we need to search what is the level of 4. So for 0 we can see it has level 0, 1 and 2 has level 1, and this has level 2. So 3, 4 and 5 is having level 2. So we have x in our graph and its level is 2, so our output will be 2. Similarly, see, this is the pictorial representation of it. So 4 is having a level of 2. Similarly, here 1 is having a level of 1. So it is returning 1 in our output. Okay. So let us first of all go to the explanation part of it. Okay. Uh, so let us say our x is equals to 5 and our acyclic graph is 1, 2, 3, 4, 5, 6. Okay, this is very simple. I think it is quite simple. So we can say if it is cyclic graph, then it can be a tree. Okay, it can be a tree. Obviously, if it is not a let's say not a disjoint set of graphs, then it will be a tree only. Say this is 1, 2, 3, 4. Let's say now 5. Okay, so this is a cyclic graph. It does not have any cycles in it. And what is a cyclic graph? Let's say 1, 2, 3, 4, 5, 6. Okay, so we can say it is a cyclic graph. How? It is having this cycle and this cycle and this cycle also. Okay, so it is having 3 cycles. So that is why we are uh, using tree to represent a cyclic graph. You can say a tree is also a graph with no cycles in it. Okay, 6. Okay. Now, as we have discussed in the previous video. Okay, now see, first of all, before doing that, let us see. So x is having value of 5 and this is our 5. What is the level of 5? Let us find it out. It is having a level of 0, 6 and 2 is having level 1, 3, 4 is having level 2 and 5 is having level 3. So our answer should be 3, isn't it? Yes. Now, okay, now, okay. So what we can do, since we have studied DFS, we can make use of DFS, right? Yes, we can make use of DFS. We can make use of DFS. So for DFS, what we need a queue, and what we need a visited array. Visited array of size n. So what is number of nodes here? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay, 0, 1, 2, 3, 4, 5. Okay, now first of all, everyone is having value 0. That means they are not visited. So now what you can see, okay, we need to calculate the level also for each index. For each node we need to calculate the level also. So what you can see, either you can use a visited array or a visited map, say visited map, which will have a node and its level. Okay, both are integer types only, so we can say map of type int comma int. Okay, either you can use this. Okay, so I'm giving you options. Okay, I'll solve using one method. You can use any of it. So first method is using map of type int comma int. Okay, this one will be a node mapped with its level. Second thing you can use is a pair class, or say a visited array of type pair, not integer. Okay, and it will store a node and its level. Okay, if you know how to create a pair class, it would be very piece of cake for you. Okay, if not, you can just go and google it out how to create a pair class and how to implement in an array. And the third thing you can use is a separate level array. Okay, this is the simplest one and I'll be using the simplest one. Okay, so I'll create a level array of size 6 only. 0 1 2 3 4 5. Okay, right now it is empty. Okay, so now let us start our BFS traversal. It is a start element. Okay, mark, first of all, push start in our queue, mark it as visited, that is true. Now take it out, check its neighbor element, that is 6 and 2, put 6 and 2 here, mark 6 and 2 visited. Okay, so we need 6 now, sorry, 6 and 2. So it was 1, sorry, I marked 0 as true. So 1 will be marked as 1, this will be 0 only because we do not have any 0 node here. Okay, so 1 is marked as true, 6 and 2 will be 1, 6 is 1, 2 is marked as 1. And okay, one thing I forgot here, for 1 we will simply put 0 here because we know for the starting index will have level of 0. Now after taking out 6, what we will do, before taking out sorry, let us perform once more. Okay, we put 1 here and mark its level as 0 and mark it as true here. Okay, we do not require this one. Mark it as true here and put its level as 0. Its one's level is 0. Now what we'll do, take out 1 and check its neighbor 6 and 2. We will put 6 and 2. Where is 6? 6. Okay, so for 6 and 2 will mark it as visited, and for 6 and 2 what will do, 0 plus 1 store it here, 0 plus 1 store it here, that is their level. Okay, so we can see it is having level 0, it is having level 1. Similarly here also it is reflecting. Now take out 6, taken out, check for its neighbor, it do not have any neighbor. Then go to 2, check for its neighbor, it is 3 and 4. So mark 3 and 4 as visited and increment its value. 1 plus 1 it will be 2, 3 and 4 it will be 2, and add the same on the queue. Now take out 3, taken out, check for its neighbor, that is 5 only, mark it as true. Now Yeah, now update its level. So 3 is having level 2. 2 plus 1, put it here 3. That is the level of this one. And now what we'll see, we will check. Okay, after performing this one, now we check if x is equals to our current element I. If it is equal to this one, we will return level of I. That's simple. The only thing that we are not performing here is we are not doing bfs.add mode. This thing we are not performing here. Instead of that, we are doing this one. Okay. So let us now get into our coding part. This one. Okay. So we have a queue. We need to make a queue of integer queue. Linked list. Let me zoom it a little bit. Okay. Yeah. Yeah. And we need a visited array and visited equals to new int of size v. Now we need a level array int level equals to new int that is also of size v. Okay. Now what we'll do, we'll start our bfs traversal. So q dot add 0 and visited of 0 should be marked as 1. One thing we forgot here is arrays dot fill visited with 0. First of all, we marked everyone as unvisited. Now we will start our while loop. While q is not empty, take out the first element. Integer node is equals to q dot poll, and what we'll see, uh, okay, here what we can say, level of 0 is equals to 0. Okay, since we know the 0 is our starting index, so its level is 0. Okay, now now what we'll do, we will check for the nodes. Okay, the neighbor of this one. Okay, so for int let's say integer neighbor of our node, so adjacency dot get node, I'll check for its neighbor if they are not visited. So if visited of neighbor is equals to 0, that means they are not visited, then only we'll perform this operation. If sorry, they are not visited, what we'll do, visited of neighbor divergence, it will be neighbor, visited of neighbor will mark it as 1, and q dot add neighbor, and level of neighbor is equals to node, the level of node plus 1. So level of node plus 1. Okay, so we did this. Okay, now what we can say, if our x value is equals to neighbor, so simply return the level of neighbor. Simple. Else we need to return -1. Return -1. Okay. And what for this node? For this node also, let's say the starting node is only x. Let's see if it runs or not. If our starting node is only x, let's say our x is holding the value of starting node, so we need to put this value, sorry, this if condition here. First of all, let us submit. If it does not get submit, then there will be only one edge case that I am talking about. Okay, let us see if it gets submits or not. Okay, it got submitted. Okay, so in the previous code also I have done this thing, but I think this should be done here. I think then also it will get submitted if is equals to node. Sorry, versus node, then return level of node. This one should also run. Yeah, this one will also run. Okay, so both are the correct. Both are having the correct. What you can say, the concept is same. Okay. So but try using this one. Okay, this one. If we need say what I did here is if condition I've not put in our for loop. Okay, because in for loop we are not checking for this node, and let's say this is our starting node, then we are not considering our starting node only. What I'm talking about is what I'm talking about is let's say this is our tree 0 1 2 3 4 5. Okay, we talked about 5. It is having a level of 2. Okay, but what if our x is having a value of 0? For 0 we are not checking. Let's say what we did, visited of start is equals to 1. That means this is marked as 1 in our visited array. It is marked as 1. Let us use a clear space. Okay, let us use a clear space. Let's say this is our graph. Okay, 5. It is having level 0 1 and this is having level 2. Okay, now what we did, I'm not making the queue, just the visited array 0 1 2 3 4 5. Okay, yeah. So for 0 what we see, 0 is marked true. Okay, now we check for its neighbor. Okay, and the level of 0 is, let's say 0. We have added 0 in the beginning only. See, in the beginning only what we did, the level is marked as 0. Level of 0 is marked as 0 here. Okay, and previously we were storing this if condition here in this part. Okay, so we were not checking this condition for our starting node, we were simply checking for its neighbor. Okay, but what if our x is given as 0? That is our starting element, so we'll skip this element now. So clearly, if, let's say if I use a custom input, okay, so let's say this is an array, input is equals to 4. Okay, input is equals to 4, custom input. So if we say input is equals to 0, if we say input is equals to 0, and what I did is remove the if block from here and we put if block here, it will give an error, I guess. Okay, we did not got the error. Okay, sorry, we are checking for node only now. Right, we are checking for node only, not for the neighbors. We are checking for node in each iteration. Okay, so that is correct only. Okay, both condition is correct if we use if here or here. Okay, but we should not use. Okay, what I did was Neighbor. I was doing neighbor in the previous condition. Okay. If I do this, we will get error here. We'll not get the desired solution. We'll get -1, I guess. See, we are getting -1, right? We are getting -1. Why? Because for the parent node, the starting node, we are not having any check. If we do run also, it is getting submitted. Okay. I think GFG has not added this edge case. Okay, see, it will get submitted every time. Right, correct. Correct attempt. But if we add this custom input, starting index is 0, let's see if it is not mentioned in our test cases. Auxiliary time complexity is V, and let's say X is from OK. It is already mentioned. If it will be always from 1 to node V. Okay, so it cannot be 0, right? Right, then it is correct. Then it is correct. But if this condition was not given, na, if this condition was not given, if it was from 0 to V, then it would be wrong. Then we should use the previous thing that I have added, that was this one. Okay, so you should check the constraints. I have not checked the constraint, that was my fault. But since constraint is a very vital part of the code, so I hope you understand the main part of the main intuition, main concept of the code, and also why to check constraint also. Okay, thank you very much for watching.